So we're going to prove that the three angles in any triangle add up to exactly 180 degrees. Now 180 degrees has a name, it's called a straight angle, right? That's 180 degrees. So two preliminary facts that we need, besides recognizing an angle of 180 degrees. Number one, if two lines intersect each other, then this angle here and this angle here, the angles that I marked red, have equal measure, and they're called vertical angles. Now suppose we have two lines that are parallel to each other, and then a third line hits these two lines. Actually, that third line has a somewhat poetic name. It is called the transversal for the parallel pair of lines. Then this angle here has the same measure as this angle here. Okay, so this is it. This is all we need. Okay, so let's prove this. We just started with standard labeling, so we're going to use that. So we're going to draw a triangle. Unless it's specifically stated, try to avoid isosceles or right triangle. It's not as easy. Okay, so this angle is alpha, this angle is beta, and this angle is gamma by standard labeling. And so we're going to prove that the three add up to 180 degrees. The first thing we're going to do is we're going to extend the line between vertices A and C. We're just going to extend it. And while we're at it, we're also going to draw a line parallel to this line, but going through point B. We're going to extend these sides. Oh, we didn't give it a name. If this is line B, let's call this B prime. This way, the fact that they're parallel is very easy to keep in mind. Okay, so here's what we're going to do. The angle alpha that I'm marking blue right now has got to have the same measure as this angle here. Why? Because line AB, the line connecting points A and B, is a transversal line for the parallel pair B and B prime, right? So here are two parallel lines, a third line hitting the pair, so these corresponding angles must have equal measures. We'll do the same thing with gamma here, which I'm marking red. Again, now this line here, the line connecting points C and B, is a transversal line for the parallel pair B and B prime. Therefore, the angles marked with red must have equal measures. And now beta, which I'm marking with green right now, and this other green angle I'm marking right now are vertical angle, right? So they must have the same measure. Notice that we just use these two things, the transversal and the vertical. And now we need to notice two things. Number one, if you want to add alpha plus beta plus gamma, you can do it here. And number two, when you pile up these three angles next to each other, they form a straight angle. So these three angles add up to 180, therefore these three angles must too. And we proved our theorem. So the three angles in any triangle add up to 180 degrees. Thank you for watching.